Welcome to Walkabout the Galaxy, the whimsical astronomy podcast where the science is universal, the opinions are personal, and the sponsor payments are past due. I thought, was that in your department? Collections?
It might be. Maybe that's why they're past due. I haven't been.
You need to get on that, yeah.
If you could please check into that. 290
I'll add it to my to-do
prior
list.
sponsors
Very, very short to-do list.
have yet to pay. We are Strange, Charm, and Up, the Astroquarks, also known as Josh Caldwell,
Addie Dove.
And Hannah Sargeant.
coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. See our hashtag shorts and our Walkabout shirts on YouTube. If you'd like to get one of those shirts and support STEM education at the same time, send us an email at wtg@ucf.edu. Our stumper today is, I think we've done ones before that were like spectroscopy or photometry.
Mm-hmm.
This one is spectra or pictures, basically. And I have to specify it's not color pictures. So it's a broadband or narrowband, but no spectral information in the picture.
I see.
Okay.
Right,
Okay.
yeah.
Sure.
So it's essentially it's an intensity image. You can choose your wavelength that image is at, or have it be a very broad wavelength or whatever.
Sure.
But you have no information about how much light is coming at each different wavelength in your image. Or
Oh my gosh.
spectrum, and the spectrum is not a spectral image, obviously. It's just a single
It's not
graph.
hyperspectral
It's
image.
just a single graph. What do you go for?
Like, like, it depends. It depends.
I'm sorry, that's not one of your options.
We watch another YouTube person sometimes, and he has a whole segment about where he says it depends.
Oh.
That's not
We
this
don't do
YouTube
that.
channel.
Not on
It's
this.
not-
I like pictures.
Yeah.
I mean, because not only can you learn a lot, you can then. It's just, I feel like it gets more excitement and
You
more
can put
interest.
it on a t-shirt.
Put it on a t-shirt. You can.
You could put a spectrum on a t-shirt.
I mean,
You can.
but
no, I'm going to.
but in terms
There's-
of
Challenge
engagement,
accepted.
There's a classic album cover that's Arecibo, like waves.
Nice.
I
Oh.
forget,
I just feel like pictures are the thing that really appeals to a wider audience, and I like that.
Well, I'm talking about you. I'm not talking about...
Yeah, and I like.
that's what she wants
You're
to
in the
appeal.
wider audience.
She wants
like-
to appeal to the wider
I like
audience.
appealing to the wide. I like getting other people. I like seeing people who aren't interested in space suddenly interested in space.
Those people don't exist, Hannah. Just kidding, they do.
Not anymore. Not once I show them pictures.
That's
then
right.
they are all interested.
I see.
So
So that's a tool you want to use to...
Because
Yeah.
I mean, it's scientifically interesting as well, but it's just
So-
there's more to it.
I mean, a
Given-
lot of the data we collect is images, right?
Given what you just said, Hannah, I have to ask you, why are you doing an audio podcast?
because you asked so nicely.
Okay.
Sometimes it's audio and visual.
Yeah. Well, I'm coming down for
You're gonna say
Spectra.
you're Team Spectra, I
I
assume.
have to. I
Yeah.
gotta stick up
I'm
for
not
Spectra.
surprised.
Yeah, look
I
behind
would-
you. I mean,
You're
That's
a
not a
Spectra guy.
spectrum.
oh, that's true.
It's sort of like a photometric time series.
That's
It's not
true.
a spectral
It's squiggly lines,
information,
though.
but it is a squiggly line. But
There's
I
a lot of
love me
information
some
in a
squiggly
spectrum.
lines. Yeah, I love pictures for sure, but I'm like blown away by how much you can get out of a spectrum. But it's true.
It's
that they
okay.
are,
You're just wrong.
Huh?
I said it's okay. You're just wrong.
Oh, okay. Well, today we'll have our Artemis Corner, our new recurring
Are we
segment.
gonna have
Segment.
our JWST
In our-
feature and
our-
our Artemis Corner?
The Artemis Corner and the JWST feature. We need to come up with a better
yeah, I
name
don't
for
like
that.
the feature. I forget what I called it the first
JWST
time.
hallway.
The JWST. Yeah, I like that JWST.
But
JWST.
first, this episode of Walkabout the Galaxy is brought to you by the Hertzsprung Gap.
Ouch.
Excuse me. Ready for some adventure in your life?
Always.
Cross the Hertzsprung Gap. If a star can jump across several spectral classes in a relative blink of an eye, you can absolutely make the leap across the Hertzsprung Gap and leave that run-of-the-mill main sequence behind. And while you're on your way to the bright lights of the red giant branch, you can marvel at the pulsating glow from the instability strip.
Ooh.
So if you're looking for a change of scenery, take a hop, skip, and a jump over the Hertzsprung Gap to brighten up your life. the Hertzsprung Gap. For every generation, there's a gap.
The
Gap.
gap.
Yes.
I was like,
I know this one.
The hop, skip, and jump are the bus lines in
In
Boulder,
Boulder,
too.
right,
I always love
yes.
that.
Yeah.
I like how topical it is, considering that we were talking about potentially Beetlejuice being.
Having just jumped the Hertzsprung
Yeah.
Gap.
That's
Yes.
why
So I
they heard that
get
episode
it.
and decided to sponsor.
Yeah,
Yes.
they were happy with the promotion.
Yes.
Yeah.
But they still do need to pay, so make sure you get on that.
I'll get on that.
Okay, let's take a walk down the JWST hallway
Mm-hmm.
Do we want to do
on our way to the
spacesuits
Artemis Corner.
first?
This sort
This
of
is
They're
a-
all related.
It's
I
all
guess,
a,
now. Yeah, that's
a
true.
it's
type
all
of
part and
space
parcel of
news.
the same thing.
So, have you seen the latest image that has come out of Jupiter, thanks to some JWST
Yes.
data?
Magicry.
Yes.
hmm It's
Yeah,
pretty.
It's super cool.
So,
It is.
people, if you haven't seen it, you need to go check it
We'll
out.
post it.
We will do that.
So this is an image of Jupiter taken in the infrared, if I'm correct, because that's what
that's what
JWST
JWST
specializes in.
Yes.
It's not. It's what it only
It's only
does.
what it
Also,
Yeah.
it's not like it does imaging, but, like visual, kind of in a crappy way.
No.
You know, or does like crappy ultraviolet.
It is
It
just-
doesn't. Yeah.
It does it well. Does infrared only and infrared well.
Yes.
And so yeah, we've got these really cool images of Jupiter. They are incredibly sharp, and you can see the
Both like in detail and in like, ooh, that's a sharp.
Yeah, it is good. So you can see the auroras in the poles.
Which is interesting because a lot of times when we think about aurora, we think about UV.
UV,
Well, I
yeah.
do at least because a lot of detections we have of aurora on like Saturn and Jupiter
Right.
have traditionally been in UV.
Yeah.
Yeah.
And this is really shining in
Yeah.
the
Yeah.
infrared.
And like we see it on Earth invisible,
Right.
but I never think about seeing aurora in
In
IR,
infrared.
so I was excited about
Right.
this.
Yeah, and so we can also see rings, which a lot of people forget about. Jupiter has some little rings going on.
Which is going to be. We're going to be coming back to that later.
Yeah.
Ooh.
Okay. So hold that thought. We can also see two tiny little moons, Adrastea
Adrastea
and Amalthea.
and Amalthea.
And you can also see, thank you for correcting anything that that I was about to get wrong there. And you can also see some faint glow of like galaxies in the background, that have made it through, which is really cool.
Yeah, one of the things that's amazing about these images, apparently, is
can't
like with JWST, like every picture it ever takes, there's going to be galaxies.
Yeah.
just
So
there.
cool.
Yeah, like those darn galaxies.
It's amazing.
And one of the most I find cool things about this picture is that it was put together by a citizen scientist. So a citizen scientist is someone who can access this data and can play around with it and
Which is everybody.
which is
So everybody
everyone can be
Yeah.
a citizen scientist.
Yeah,
Right.
and there's a tradition of this now with like Juno Cam. So like
Yes.
the Juno, the mission around Jupiter has always been putting its its images just like out really quickly, and like most of the cool images you see from Juno Cam
Right.
are citizen science processed.
Yeah,
which
with
is
Juno in
cool.
particular, originally at
didn't
one
even
point
have a
wasn't going to
camera.
have a camera, and it got.
Wow.
They were just gonna have spectra.
No,
They
they
had
were
other
data,
and then they
but-
realised the fault in their ways.
They
and
did.
They
put
did.
the camera on.
And they put it on as an APO
Yeah.
payload, as an education payload.
That's right. Yeah. So it was like they said, okay, we can lower the cost by basically outsourcing to the world a lot of the sort of
Yeah.
production of this, and then making it. And they've also produced some
Incredible
really stunning images.
things.
Jupiter is a very cool looking planet, I have to say.
It is.
Yeah.
It is.
It looks nice, and it's quite bright in the morning sky.
And the
these
great red
days.
spot looks pretty cool. It like it really pops in the
Yeah.
IR as this like
Yeah.
bright white spot.
Yeah, it's
Yeah.
bright white, which they say means that it is higher in the atmosphere. So it's like so you can kind of
So is it
see.
cooler.
I think,
No,
no, it's
no,
reflect. They
it's
said
the-
it's reflecting.
Different.
I thought the great red spot was deep. I thought it was a
was
cloud-free region, so that you were seeing deeper.
So it says the Great Red Spot, a famous storm so big it could swallow the Earth, appears white in these views, as do other clouds, because they are reflecting a lot of sunlight. The brightness here indicates high altitude, so the Great Red Spot has high altitude hazes.
Interesting. I think in the visible.
Yeah.
Interesting.
I-
Well,
Yeah.
we're gonna have to follow
We'll
up on
follow
that.
up on
Yeah.
Yeah. The most of the colors that we see on Jupiter, obviously there are compositional differences, but we see those different compositions because we're seeing down to different depths.
Right.
So just like if you look at a picture of the Earth, if there are clouds, and if there are no clouds, you see the ground, so you see whatever color that is underneath.
Yeah.
It's sort of like that with Jupiter.
Exactly.
They have different things condensing at different altitudes because of the temperature profile of the atmosphere.
Yeah.
In any event,
Yeah.
cool stuff.
And I just wanted to mention just a bit more about the scientist, the citizen scientist. So it says her name is Judy Schmidt, and she has no educational background at all in astronomy, but she won a contest processing some Hubble images. I think she came third, and she's just been like just super into this thing ever since, and like processing space imagery.
There was a Hubble image processing contest.
It's called Hubble's Hidden Treasures, which invited the public to find new gems in Hubble data, and she came third out of nearly 3,000 submissions.
Fun.
That's kind of that's mind blowing that that's a thing.
Yeah, and
too.
it's so
like
cool. So anyone can
American
do this.
Idol, but
Well,
way
image
cooler.
processing.
Hubble Space Science Image Processing Idol.
Yes.
Okay, cool. I think we've made it down the JWST hallway to the Artemis Corner.
Welcome to Artemis Corner.
Artemis Corner is getting really exciting.
It's getting busy.
It is fueled up. Well, part of it is. The solid rocket boosters have their scary fuel in them, and they're starting to do loading of some of the other things on the vehicle.
The main engines on Artemis, I believe, are liquid hydrogen.
Yeah, those are hydrogen and oxygen.
And so I've also been attending. Both of us here have been attending League this week.
The Lunar Exploration Analysis Group.
Exactly. So they've been getting
Analysis,
a lot of
not advisory.
Might be advisory.
I should know. I'm
should
technically
know
on
if
League.
you're on it.
And so they've been giving lots of updates, which includes some Artemis updates, and they showed us a very. It looks very basic.
Analysis.
It is analysis, okay.
It's the elevator that was going to be on this Starship lander, which will take the crew to the surface of the moon. So they're saying that I think they're going to demonstrate. So they're going to demonstrate their SpaceX lander before they put crew on it. And they said
That's a good plan.
it's a good plan to test it out, but they said it's going to be a skeleton version, so it's not even going to be the final version.
Of course it's not. This is like...
Yeah, so when I saw that, I was thinking about in The Martian, by Andrew Weir, when he takes off and he's like ripped off.
That's
all
what it's going to
Has the
be!
hatch open. There's like a hole in it.
So it's kind of, they're really working towards an extremely tight deadline. They said, we'd like to have it fully capable, but it only needs to be kind of partially capable. And they also said
I mean, I guess it's fine if like the seats don't have padding on them, right, if there's no humans in it, but like what does it mean? Like how stripped down does it mean?
Right.
Because
they said that one of the things NASA's requirements for the HLS mission, so this is the Human Landing System missions, ends once the astronauts are returned to Orion. So we don't tell basically SpaceX to do anything with the lander, and it's up to SpaceX what they want to do with it, which I find it doesn't really go with the Artemis Accords, which they fall under, which is they have to be, careful with how they behave in space, and if you just leave it up to SpaceX to do whatever they want, I don't trust them.
Yeah, let's talk about the Artemis Accords. So
the Artemis Accords are
was there an updated timeline for that Starship skeleton test? I don't remember.
I can't see it with a quick scan.
Yeah.
But that test will be landing a Starship on the moon.
Yes.
But a skeleton version, and it's getting to the moon with the Super Heavy.
Assuming.
Yes, I think so.
Okay, which is also yet to fly.
Sure.
So we're a ways away from a lot of this stuff happening. So
I think Starship doesn't have to have Super Heavy
to get to the moon.
How
else does it get there? I mean, what else?
Hopes and dreams.
Money. I think that's expensive.
Just a lot of money.
Yeah,
you just make a giant pile of money. It's a new space elevator.
Right.
It's just a giant pile of money.
Yeah, I think that's the only thing it can go on top of.
That's probably true. But you don't need...
We're expecting that Super Heavy, is that what it's called now?
I think so.
To go sometime in the next 6 months-ish on its first single orbit around the Earth test flight.
Yeah.
Because they'll also be leaving a bunch of fuel up in space ready to dock And
in something, I hope.
oh no,
Yes.
just an open hose.
Just some cloud of
Well, one of the challenges of that is
hydrogen.
we actually don't know how to do that. We don't know how to
Right.
refuel in space.
There's so much that
There's
we
a
have
lot
to
of the physics
achieve.
of that we don't know.
Yeah.
Anyway, okay, Artemis Accords.
So Artemis Accords, so these are basically kind of the rules and regulations that people who sign up to the Accords promise to abide when
Regarding the moon and the moon in particular.
the moon in particular, generally like kind of space exploration and use of resources and just general being well behaved
there
in
was
space.
some older space treaty.
Yes, the Outer
from the
Space
60s
Treaty.
or so.
Yeah, and that is kind of outdated because it was very useful at the time, but one of the kind of regulations to stop basically warfare in space, it was saying that you can't own anything in space. You can't you
own a
can't
piece
put
of
a
the
flag
moon.
and then say you own it and that's your
Right.
territory. But ultimately, if we're going to be travelling further and deeper into space, we need industry involvement. There needs to be a reason for. There needs to be a commercial interest, which involves being able to profit
Right.
from space, which
Okay.
involves some sort of ownership. And so there's a lot of work going into trying to rework some of these policies and getting people to agree to follow them.
Yeah, we've had a number of, over the years, a number of stories about NASA getting their noses seriously bent out of shape about people owning or selling, the odd particle
Yeah.
from the moon or something like that. But now we're some collective subset of humanity is sort of counting on that commercial incentive to help build a space infrastructure in some sense.
Yes, and I think ultimately it is in everyone's best interest to follow these sorts of rules, but these regulations kind of need to be put in place. The problem with the Artemis Accords is it being Artemis and it being US, it's very Artemis and US. So international parties such as the Russians aren't necessarily, or Chinese aren't going to jump at the chance to agree to a US rule and regulation.
So there are 20 signatories, I believe, so far. I know Russia is not one of those 20.
Correct.
Is China?
No.
Okay.
And
Those
so
are some two big notable absences.
yes,
Yeah.
but this is what. So I am involved in some other things which are trying to consider all parties, not just it being from a US NASA perspective. So there are other things going on. It's not just like the Artemis Accords is the only guidance of how to behave in space.
Yeah.
But it's just an example. So that's why it's relevant to SpaceX, because I was just reading here, presumably any agency who signs up to the Artemis Accords, if they have commercial vendors or whatever they're called, I think they have to automatically follow the Artemis Accords as well.
Yeah,
but
that's one of the things about the Accords is it's interesting. It's one thing for countries to agree to them, right? But for all of this, at what point do corporations stop doing have to?
Yeah.
I mean, if they operate within the U.S., right, you assume they have to follow U.S. regulations, but I
Right.
don't know. Things get messy.
It's a very messy space.
Yeah.
And if we're talking about colonization, that means somebody goes there and they have their little house on the Mare. Oh, little house on the Mare.
This is an upcoming.
Yeah.
We'll talk to Andy Weir.
This is a low-budget sci-fi.
Little house on the Mare, or your little house on Mars. Little house in the valley.
Now I'm trying to think what the other little house books are.
But the thing is,
people are going to say that's my little house.
yes,
And it's sitting on my little piece of the moon or Mars or whatever.
and people don't we don't like it when other missions go to the same places that existing missions are already at. So
Right.
you want to have some sort of exclusion zone, so that people, if you land, you don't then destroy other people's landing sites and things.
I have to say, I'm not worried about this at all, because the history of humanity is one where people expanding into new areas has just gone perfectly smoothly,
really well behaved,
peacefully. Everybody has worked things out to mutual advantage with no downside.
I
So
was
it'll be fine.
I was on a panel last night, which will air on Are We There Yet? And locally on WUCF also. But and Dale Ketchum was on with us, and he had some very similar comments to make about the better angels and the nature of
Right.
humans.
It's a
and
difficult
how
one.
great-
Staking your claim.
Because
Mm-hmm.
up until this point, it's mostly been scientists who've been leading the way in space, right?
Yeah.
And so we have our own sort of
Oh,
morals and
we're
ethics.
So good.
We're so good
We're
at that.
We're better than.
Well, as
Right.
in because it's so much of it is about preservation of certain things. There's a kind of unspoken rules and behaviour kind of that we abide by, and
There's a
there
lot of unspoken rules and behavior that some people also abide by that's not good. So.
True, but it's scary when and the reason that people are
Everyone.
going into these places is perhaps for profit rather than for
Or
knowledge
military or-
But
military.
it costs money to do this stuff.
It does. It's
Yeah.
necessary. It's just
So
finding
either-
the balance.
Well, the
Either-
other point too is that usually all of this stuff, like the laws, come after. Like in all of these forward
Right.
pushes, right? Laws come after you go and do the things. And it's really hard
Something
to make
bad
laws
happens, and
beforehand.
people go, "Oh, gee, this is a bad
But people
thing."
are trying. People are really trying.
I
to-
know, yeah.
Which is
Yeah.
good.
And which is good.
Yeah.
Yeah.
It
And
is
it's
good.
great if we can do it differently this
Yeah,
time.
yeah. And it is harder to get to the moon than Oklahoma, for example.
I mean, yes.
Are we invading Oklahoma?
We
the
did.
The Oklahoma Sooners
Yeah.
are called the Sooners because the people who live there are the ones who went in there sooner
Sooner.
than everybody else.
And they were squatters. Yeah, it was
Yes.
like land grabs.
There's very
Thanks
there's
for
a
our
significant
listeners in Oklahoma.
lack of creativity with these names.
In any event, you have some space news because it's now public information about
Oh, yeah.
NS-23.
That's true, I do.
Tell us about
NS-23 is Blue Origin's next New Shepard suborbital launch, which is slated to fly out of West Texas on Wednesday, August 31st.
Yep.
Public,
With one
yes,
of-
they
with
public
your-
newsed it
With
yesterday.
your payload on board.
With my payload on board. So this is ERIE, the Electrostatic Regolith Interaction Experiment.
Match.
Obviously, which is its second time flying. It flew almost exactly a year ago, actually.
On the last
payload
flight,
flight.
yeah.
It said that in the press release, and I was like, oh yeah, that's right. It
Yeah.
was a whole year.
So
But
was
I've
this
flown two
always
human
was it always
payloads.
planned to have two flights? Or
Yes.
Okay.
Yeah.
Cool.
So it was always planned to have two flights, and so
What changes have you made since the first flight?
we had a few issues with a couple of mechanical things on the first flight, so we've
Fixed 'em.
corrected that, I think. And there's a few just operational things that we changed. So like the experiment goes and it's automated, right? So it has to be triggered, and we trigger things based on different stages of the flight, and the experiment runs and all of these things. A door opens, we take measurements. But like when we were doing things, we adjusted like that a little bit based on how it performed in the last flight.
Yeah.
That's
And there's
most of it.
there's
We
over
didn't
30
change too much.
payloads. on
There are a
this.
lot. Apparently,
Yeah.
it's going to be quite crowded
Yes.
out there.
How many people are you taking with you?
Just
to,
me and Jay.
Okay.
Yeah.
To the West
to
Texas
West
launch
Texas.
site.
WTLS.
Yes.
yeah,
What's our
it
other
should be
space
fun.
news?
There's more space news.
You said you had space news, and then
Oh,
you
I-
were surprised
I
when I
don't-
mentioned New Shepard, so I assumed you had something else in your queue.
I don't think I do. I think I
Okay.
was going to talk about Artemis and there was
Jupiter?
something else. No,
Okay,
there
well-
was
Return
something
to the
else,
corner.
but-
Well, before we do our dive into some
science.
planetary stuff, let me give you your trivia for today.
It's a
which
good thing Jim doesn't listen to the podcast because he's going to be real disappointed by our lack of cosmology stuff recently.
We had some.
I
We
know.
had some.
Just
We had astrophysics. So your trivia for today is up my alley. We've been down the
got squiggly
JWST
lines.
hallway to the Artemis Corner, and now we're going into the Colwell Alley.
Colwell Alley.
It's about planetary rings.
Colwell-y.
Ooh.
Some basic trivia.
You like planetary rings.
I do like planetary rings. Planetary rings been very, very good to me.
We're going to talk some about planetary rings on one of the panels at
DragonCon.
DragonCon,
Very nice.
which is
Next
coming
week.
up next weekend.
Are we?
I think we have like a planetesimals one, so I figured we'd talk
Okay.
about planetary rings too.
How many planets have observed natural planetary ring systems? That's the first
Solar
basic
system
question.
planets?
How many they observed?
Oh,
So I said
come
observed.
on.
Do they have to be planets? Can they be small bodies?
That's an excellent question, and you
Thank
get
you.
bonus points for that. Even though I'm philosophically opposed to bonus points,
Yes.
you get bonus points for that question.
Thank you.
But no.
But no. Okay.
Okay, but you do get
Sorry,
the bonus
Sharif.
points
Oh.
for catching that. No, how many planets have observed natural ring systems?
Okay.
So natural means can't count communication satellites around the Earth.
Okay.
And then how many named rings are there around each of those planets?
Oh, Jesus.
So that's what will be coming. Those are trivia.
I hope you're ready for some more stabs in the dark answers from me.
I'm always ready for your stabs in the dark.
I don't think I've got a right answer in a few months on trivia.
You started off. We were talking about this the other day.
I peaked too soon.
Peaked too soon.
Yeah.
Started off on a high point, and it's gone downhill.
So one of our topics jumping out of the solar system is about a new exoplanet that was discovered by the Transiting Exoplanet Survey Satellite, better known as TESS. And then some follow-up observations with ground-based telescopes to figure out what was going on. So this planet...
And potentially longer-term follow-up with JWST.
Yes,
So maybe it'll show up in the
undoubtedly.
JWST corner.
JWST can do so much.
JWST hallway.
JWST hallway.
Yes.
Okay.
We'll come up with a better location
JWST.
for the JWST salon or whatever. But this object is TOI 1452b.
Naturally.
Classic.
I don't know this, but I want to think that TOI is TESS object of interest.
It is. Good job.
All right. And so
Because Kepler things were Kepler KOIs,
Were
Kepler
they?
object,
Okay.
and that just means that like
something's
it's been
seen
detected.
something
It's an
there.
object that's probably been detected, and we think it's an exoplanet. So it's an
Follow-up.
object of interest because then you'll do follow up to
Yes.
confirm that it's an actual. And I think it might get a different name if it's
At some
confirmed
point.
and followed up on.
So TOI 1452b is a transiting super-Earth. And we've mentioned the JWST hallway and the Artemis Corner and the Caldwell Valley.
No.
No, the
Alley.
Caldwell
Caldwell Alley.
Alley.
Yeah.
The valley's cool though.
It is. And guess where TOI 1452b is?
In a valley.
It's
in
in
the
the
Radius
Radius
Valley.
Yes, which is a term I had only learned from you just a few minutes before we started recording.
Mm-hmm.
That's,
Tell me more.
Yes,
I
what is the
wasn't
Radius
listening.
Valley?
The Radius Valley is just like it sounds. It's in our discoveries
Scientists,
of
man.
I know, we're the worst. So typically we talk about sort of the bigger classes of like sizes of exoplanets that we found, so
Right.
like super Earths, mini Neptunes, or sub Neptunes or something like that, right?
That's
So there's
right.
these different size classes, and that's oftentimes mass or radius, but the Radius Valley specifically, that apparently there's this really interesting, so there's sort of a peak around 2.5 or 2.4 Earth radii
Okay.
of detected planets, and a peak also around like 1.3-ish, but in between there's a valley where we don't see a
don't
lot
exist.
of.
And
They
that-
do. We have a few,
Oh.
but just a lot fewer statistically significant.
That's a really interesting figure, and it's obviously not an observational selection effect.
No.
Because the things that there's nothing that would explain that in terms of how we detect these planets, that
Mm-hmm.
dip there. So it has something to do with how planets are formed. And also interesting about that is in our own solar system, we don't have anything at either of those peaks.
No. Yeah.
All our terrestrial planets are all well below 1.3 Earth radii. We've got 2 at 1 and 1 at 1/2.
Yeah.
Right, and then the next ones we've got are at 4 instead of at 2.5. Right, Jupiter, Uranus, and Neptune are at 4 Earth radii. So our solar system would be out in the wings of the distribution of planetary sizes that we see in the exoplanets. Just another sort of odd thing. But this planet is in that Radius Valley. It's 1.67. Give or take a little bit, times the size of the Earth.
Yeah, I was just going to say there's a couple theories for the Radius Valley.
Go ahead.
And a lot of them have to do with formation techniques, like so we have a bunch of different ways that we think planets form. And so some of the theories are that maybe there's photoevaporation, so you just don't have the right amount of material to form. Some have to do with like early mass loss. But there was a newish paper that came out at the end of 2020 that looked at potentially having to do with the stellar population that these are forming around, and if like where stars are forming has an influence on that. There's not a great answer yet, though.
Yeah, so something for further study. I'm intrigued by it because
I know,
I wasn't
yeah.
aware of it. This particular star is in I was going to say it's in an unusual system, but that's not really true. It's in a binary star system, which is not unusual at all.
Mm-hmm.
It's maybe a little bit unusual to see planets in binary systems, depending on exactly what kind of binary system it is. This one is in a system with two stars that are separated by about 100 AU, so about the diameter of Pluto's orbit.
Mm-hmm.
And it's in a tight, close-in, smallish orbit around one of those stars with an 11.1 day year. So it takes it 11 days to go around the star.
It's so fast. I try to think about that sometimes.
It's scary.
Bonkers.
Yeah, and so the star is less massive than the Earth. It's an M dwarf.
Oh, I like
So
a good M dwarf.
it's a cooler star than the sun. I think it's
cooler.
I said Earth earlier when I meant to say sun, but in
You
any
did.
event, it's orbiting a star that's less massive than the sun,
Mm-hmm.
more massive than the Earth,
That makes sense.
and its equilibrium. We haven't measured its temperature yet, but perhaps
dwarf.
something that JWST will illuminate.
But we haven't measured the planet's temperature?
That's what I mean.
Yeah.
The planet's temperature, right? The star's temperature is about 3,200
Because
Kelvin
it's an M dwarf.
compared to the sun, which is about 5,800 Kelvin. So significantly cooler. So that means that even though it's much closer in, the temperatures aren't that bad. The sort of you can calculate if you put a thing that far away from that hot a star, about
Yeah.
how hot will it be. Of course, it depends on does it have an atmosphere and how bright or reflective, blah, blah, blah.
Yeah.
In any event, the equilibrium temperature for this place is about 326 Kelvin.
Ooh.
That's warmer than the Earth,
Yes.
but it's well below boiling water, which is
Which is-
373 Kelvin.
Well below.
So it's around 50 C. It's kind of like a summer in
Toasty.
London
Oh, don't.
this year, right?
Yeah, the desert.
Yeah. So an interesting planet that what they've been able to do is determine its mass
Mm-hmm.
combined with its radius
That's good.
determines that it has a very large water mass fraction.
So this is a
exciting.
density calculation, not like a spectrally observed water signature.
Correct.
But JWST could observe water.
Correct.
Potentially. Okay.
This is quite an object of interest.
Yes.
It is, yes. It's now
With a
a-
capital
it's
I.
now- It's now a WOI. Walkabout object.
Oh,
right.
Okay. I was going to
Thanks
say,
for
I was
walking
going to
us through
say
that.
QTOI.
Quite.
Because it's quite a test object
see.
of interest.
Mhm.
But
Okay.
and that sounds cute. But
All right. In any event, it
Oh,
has a
boy.
water mass fraction of something like, 22% with gigantic error bars. Okay.
yeah, I mean the big thing so is if you know the mass and you know the radius, you figure out approximately what the density is, and we do this all the time for the terrestrial planets and the moons and all of that. But and with exoplanets, it's interesting because we don't. It's still hard to figure out how much of the mass or how much of the radius is like atmosphere versus
Right.
core. So there's a
Sort
lot
of
of
tricky
like.
to figure that stuff out.
So, but they do. I mean, we have pretty good models knowing the temperature, the rough temperature that it would be, and where it is that help us
That help you
constrain it
understand,
more.
like, here's what I think would be there. Yes. And
So that all goes into the model.
Yes. And if you use Bayesian approach, which was a previous sponsor, I believe,
Probably.
where you use common sense as well instead of just rolling the dice to figure things out. So it may have as much as 20, maybe actually even more than 22% water mass
Whoa.
fraction, but probably at least 10%. So it's potentially what's called a water world, and I always think of the planet in the Star Wars where they made the clones for some reason.
I've seen that one.
Mm-hmm.
Okay.
I can understand this reference.
Right.
Yay!
Hannah and
Let's
I,
go.
before the episode, were struggling a little bit with finding some common cultural touchstones.
I'm just
That's a
constantly.
theme.
I'm just constantly letting him down.
In any event,
No.
it is a prime candidate for follow-up
That's
by
exciting.
JWST, so that'll be fun to see.
I learned of a new telescope reading this article. The Mont Megan. I'm going to say it wrong. It's like Mount Megantic. Mont Megantic. And I thought that was a funny
French?
name. Yeah, it's a French
Okay.
French observatory.
Is it French or French-Canadian?
It's French Canadian.
Yeah.
That's true.
So we'll follow up. I'm
See
looking
when we
forward to
come back.
hearing more about TOI 1452b
Yeah.
in the future.
QTO.
Speaking of watery stuff, I believe you had a water note, Hannah.
A water note.
A water
A
note.
water note. Notes of water.
Notes of water.
This beverage has notes of water in it.
Enceladus, I'm picking up some salts, notes of water.
I mean, yes, but we're on Europa this time.
Okay.
Although I
Yeah,
mean,
it's just-
could it
Those-
apply to Enceladus? Maybe.
That's
No,
okay.
it's fine.
Europa's fine.
Yeah.
Also has notes
Also
of
has notes
water.
of water.
Also has a few notes of water. So we have
The terroirs.
there is some research that has been done trying to understand the types of ice that could be forming beneath the ice sheets.
Could it form Ice 9?
Oh man,
What's
Ice 9.
What's Ice 9?
Oh, here we're back to our cultural
we go.
touchstone failures again. Have you heard of Kurt Vonnegut?
Nope.
Oh,
Okay.
really?
She had really...
See, constant letdown.
Right.
Yeah, that's not a letdown as much as just a surprise. Like I haven't read a lot of him, but I know him.
So shoot, now I can't remember for sure which book Ice 9 is in, but it might be Cat's Cradle, but in any event, ice does come in many different forms.
It
But when I
does.
read this book when I was a little
Cat's
a
Cradle.
kid, Cat's Cradle.
Yeah.
When I read this book as a kid, I just thought this is just wacky sci-fi type stuff, but it's not. And actually, Kurt Vonnegut's brother was an atmospheric cloud scientist.
Yeah.
He had the
So
inside
he
track.
had the insight. He knew about all these different kinds of water ice.
Mhm.
So you're talking about what's in Europa.
Well, potentially. They're trying to understand or kind of predict what the types of ice could be beneath the ice sheets of Europa.
And when you say types of ice, you're not saying is it water ice or CO2
No,
ice,
we're
or
talking
you're
about
saying
how-
type of water ice?
Yeah, type of water ice. So how does the crystal structure, if it has crystal structure, form and the
Right. So
consequences of that?
their water ice can come in what's called amorphous.
Which
Yeah.
is like glass, there's no structure.
Right. And
To
then
the
there's a
bonds.
whole bunch of different crystalline forms.
Exactly.
Yeah.
Which
Yeah.
has these Roman numeral designations, which
Right.
does in
Yeah,
fact
if
go
you
up to
really
9.
wanna
Goes
read
up
about
to
it.
at least 9. Yeah. Yeah.
So there's been some investigations of these ice sheets in Antarctica, some Antarctic ice shelves, and they're interested in the ice that forms beneath the surface ice and at the boundary with the ocean or beneath it. So how is the ice sheet
At the-
growing
Downward.
downwards?
Okay.
Yeah.
Okay,
All right.
and so there's
So that's right. The analogy to Europa. Europa is a big ice sheet on top of a water ocean,
yes.
like some of the ice sheets in Antarctica are giant.
Exactly.
Okay.
And so they have been looking at ice cores of the Antarctic ice shelf at different
They better get
depths.
a bunch of those and save them.
Sorry?
They should get a bunch of those and
They'll
save
be
them.
Yeah,
historical
because
relics
they won't
pretty
last
soon.
particularly long. And they found there are two types of ice that are forming. You have one of them is called frazzle or phrasal ice.
Let's have it be frazzle.
Frazzle ice.
Miss Frazzle.
And this is where you end up with like these small millimeter-sized ice crystals that kind of develop within these super cold, almost, I don't know what they call, not a jet, but like these just.
The crevices and stuff.
I have lost my place. in
Okay,
this
keep
thing to
going,
find it. And here we go. Frazzle ice is most likely to accumulate. Yeah, in these small scale rifts and fractures, basically, and so you get these small little ice crystals, and they kind of, because they're buoyant, they then move upwards and collect on the base of the ice shelf, and so you end up with this almost. They call it. They've described it like it's snow that's flowing
Moving up.
upwards and collecting beneath the ice shelf. Or you can get the ice that forms basically at this boundary. The water that is next to the ice will then just freeze
Yeah.
into that same
Classic.
structure. Classic ice doing its thing. And so you get that ice in the really, really deep crusts, kilometre thick, multiple kilometres thick ice. But then when you have really shallow ice, when it's fractured, that's where you end up with this frazzle ice.
And it's
It's
also
kind of
that it's
snow.
thin and it like will have some cycling, so you get some melting and some refreezing and stuff like
Yeah.
that. You get this forming.
And what's interesting is that these different types of ice will retain different amounts of salt from the water around it. So the frazzle ice will only retain about 0.1% of the salinity of the surrounding water, but the what they call the congelation ice, which is this ice that just kind of
I
grows.
just made that up.
I know, right? These both sound like very made up words. But you learned about growls
That's true.
a couple weeks ago, so there's lots of fun snow and ice words.
So this congelation ice, it retains around 10% of the salinity. So because it has different amounts of salt, it has different physical properties.
When Europa Clipper goes to Europa,
Mm-hmm.
let's bring it back to space from Antarctica.
Yeah.
When Europa Clipper goes to Europa, it will not be doing any ice cores or touching down on surface or anything like that, but it will be observing all sorts of areas of interest and presumably younger areas on Europa. And I think that they're hoping to be able to say something about the interior based on what they see sort of having spilled up onto the surface. So will that tie in? Like, will they be able to make some connections about the salinity of maybe what they see on the surface at Europa back down to, okay, that's, coming from this sort of icy ocean? Or
well, one of the things that is of particular interest is that the Frazzle ice, it can, because of its shape, it can basically trap any biosignatures that are in the water around it, between the crystals.
Okay.
And so they're not expecting biosignatures necessarily on this to be around on the surface, because it's going to be coming from deep within this ocean. But if you have the Frazzle ice, then it could collect some of those biosignatures before it either gets exposed in one of these shallow ice regions of Europa. So if they could sample any of that, they might potentially detect some biosignatures if it's trapped within between the Frazzle ice.
For a future mission. We will need the Europa Accords in place as well.
Yes, indeed.
before that
I
mission
was
takes
looking up
place.
Frazzle ice, and there's a slushy beverage that is also called Frazzle, because I think it's probably an interesting, funny ice shapes.
Fun.
But Frazzle ice can cause a lot of problems too. Anyway,
Speaking of ice, do you know what's made of ice?
rings. A lot of times rings have ice.
Planetary rings are quite icy. How many planets have observed, speaking of rings, have observed natural ring systems?
25.
Interesting.
12.
Interesting. You're both really optimistic about the exoplanet
Yeah, I
thing.
was.
There
And
aren't any.
I thought there might not be
Oh.
any,
So now
so I
that-
should have.
Okay.
Now that I tell you
Can we
there aren't
recalibrate?
any, you can give a new answer if you want.
4.
Oh, yeah, 4.
You are correct. Jupiter, Saturn, Uranus, and Neptune.
Yeah.
Now the tough one.
Okay.
How many rings, and I'm using one-handed air quotes for that, are there around each of those planets? We'll
Do
just
one-handed air quotes have a different meaning than two-handed air quotes?
No.
Okay, just checking.
Maybe they do. Probably in
That's
some
just bunny
cultures they
ears.
may be.
That's just bunny ears.
Right. Let's just go from the inside out. Jupiter. How many rings? And to count them, I'm going by sort of things that are called, in the
Called like an
literature,
A-ring.
named. For example, at Saturn,
Except I
there's a
think
ring called the
Jupiter,
A-ring.
They're called.
And even though the A-ring continues into something else,
Sure.
we
There's,
call that a ring,
specifically
and
named
that's something
rings.
else a separate one
So
for
Jupiter-
the purposes of this question. So for Jupiter, what say you?
3.
Yeah, that was
Is that
my
what you were going to
guess.
say?
Close, 4.
Ah.
Okay.
Yeah,
Okay.
and they're all sort of blended together. It's all a very dusty ring system.
Yeah.
They have
Very faint.
very faint,
thin.
very not a lot of. It says why
There's
when
not,
we look
like,
at it through a
replenishments
telescope, you don't
probably-
see
yeah,
them.
yeah,
If you look
yeah.
at Jupiter with a telescope, you won't see them. JWST did because it's
JWST is a telescope, and it's all.
Yeah, but if you put your eyes up to a telescope here on the ground,
Okay.
you're not going to see it.
Yes.
So you have to collect light for a long time
Yep.
to see the light coming from the rings. They're called the halo,
Halo.
the main ring, very imaginative
Mhm.
names. The Amalthea ring,
Oh,
which
yeah.
ties
Okay.
back to
Near
the
to the
JWST
baby
picture,
moon.
and the Thebe ring.
Oh, that's right.
Saturn.
Oh, you're going to be so mad at us.
12.
7.
It's 12.
Oh!
That's the number.
I'm going to ride that
That's-
high for another 3 months in
That's
Brian
right,
Answers.
yes. That's the number I wrote down. Plus,
Is that the correct number?
well, it depends.
I can write a
Oh,
lot of numbers
don't
down.
ruin this for me.
But
She
that's
said
what
you
I've
were
got
correct.
here.
That's
all
That's,
you
the,
need.
that's the number I've got here. You
Okay.
get the point. She has the bonus points from earlier.
That's true.
That is not including some little ringlets that are sort of within the bigger
yeah.
rings. So
Yeah.
within the A
That's
ring,
like
for
counting
example,
planets and
And dwarf planets.
dwarf planets.
within the A ring, for example, there's a gap here on the back of my.
The Yankee Gap.
It's the Yankee Gap, and within that gap there is a moon.
Oh.
And co-orbiting with that moon, there is a ring. I didn't count that ring.
Okay,
Thank
good.
you.
Okay, and there are half a dozen others
Does it have a
sort
name?
of like that. It's called either the Pan ringlet or the Yankee ringlet,
Okay.
after the gap or the moon.
Or the moon,
There's actually
yeah.
a couple of things in there. So you can count those.
Complicated.
Uranus.
Excuse you?
And I wanted to say,
Oh, yeah.
I really
You were
wanted to
amused.
highlight the headline
From which
on
publication?
space.com. Emphasizing that we had previously talked about the NASA, well, not really NASA, but the Decadal Survey from the National Academies for Planetary Science highlighted a mission to Uranus as a top priority. And Space.com published a headline that says, NASA really wants to probe Uranus.
They must have had a lot of fun.
And I just
Everyone
thought,
does.
Yeah.
was that on purpose? You think it was
It
on
was
purpose?
100%
Oh,
on
almost,
purpose.
yeah.
Okay.
Yeah.
All right.
All of those are.
Okay.
Okay.
How many rings around the
Rings
seventh
around the-
planet?
5.
3.
That's why I'm a little bit disappointed, but that's okay. 13.
Oh.
Whoa.
Yeah. 10 are narrow. The original
Yeah.
discovery from the 70s from ground-based stellar occultations was 9.
Okay.
And
I
then
couldn't remember.
Voyager
these
follow-ups
have,
and additional
these are like
ground-based
tau.
observations. They're all
These have
Greek letters,
right?
except for 3 of them, which are 6, 5, and 4.
Oh.
Obviously.
So there's a bunch of Greek letters, and then 4, 5, and 6.
Is it the first 9 have Greek letters and then?
No.
Oh.
Yeah, it's because
I hate this right now.
I know. Well, it's just one group discovered some funny blips and numbered them 654, and another group discovered some other
But didn't
blips.
the IAU do something about
I
that?
know, right? They don't do
Are
that
they
with
astronomers?
rings. They don't do
Because
that with rings. Anyway,
astronomers do not have
your
good
guys are
naming
doing
convention.
pretty well. Really good with Jupiter and Saturn. Not as well with Uranus. Epsilon ring is the main ring of Uranus,
Yes.
where most of the stuff is, and it's about 50 kilometers across, which is a small ring as planetary rings go, but it's got big stuff in it. It's not a dusty ring like Jupiter's.
Right.
Neptune.
Oh, we're not done.
But then we will be done.
Yeah. I think I was thinking Neptune when I said Uranus, so I'm going to go with 3 again.
Okay.
5.
I have written down 4 or 5. There are 2 narrow,
You get a point.
I'll
Two
take a
narrow.
half.
Yeah.
like the most of the rings at Uranus.
Okay.
And then 2 broad, dusty, featureless
there
things.
one, like, really
one of which
big
has a little
wide one?
bumpy thing at the end, which is why that's the 4 or
Okay.
5 part comes in. Yeah.
It's got a bumpy thing at the end.
Yeah.
I'm happy with our estimates. I thought we were in the right ballpark at least.
Yeah, except
Well
for
done.
Uranus.
Uranus, you were a bit off on that one. It does have a whole bunch of narrow, dense rings, which is pretty interesting
Yeah, it
because
is.
it's hard to explain those.
Those rings around Uranus are pretty interesting. It is hard to explain
So I've
them
been told.
sometimes.
Well, it may have felt like a trip to the instability
Sorry.
strip. It was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe. Be sure to follow us on Facebook and Instagram to get all our updates. And check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, where you can see most of our episodes, some of our bloopers, and now silly shorts, including behind-the-scenes
Oh my.
stuff. And then you may be wondering, what shouldn't all of it be behind the scenes?
Maybe you should have left that curve down.
Catch up on old episodes wherever you get your podcasts. Follow us on Twitter.
At walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jurisic. Production assistance is provided by Logan Basinger. Thanks to our listeners in Arizona and around the world. Stay safe. I'm Josh Caldwell.
I'm Maddie Dove.
And I'm Hannah Sargeant.
We're the Astroquarks, signing off until the next episode of Walkabout the Galaxy.